Great minds of humanity, celebrating human brilliance.
On a gray Berlin morning in 1919, while Europe was still counting its dead, starlight measured during a distant eclipse appeared to bend around the sun, and a little-known physicist suddenly stood at the exact point where the old universe broke open. 2 decades later, that same physicist would sit in exile in Princeton, staring at the consequences of ideas about energy and matter, while the modern world prepared weapons powerful enough to make even genius feel like a burden. His name was Albert Einstein, but the wild hair and famous equation came much later than the struggle, because the real story begins with doubt, stubborn imagination, and a young patent clerk who refused to accept what everyone else called obvious. Einstein changed far more than physics, because once time itself became relative and gravity became geometry, modern life inherited new technologies, new philosophies, and a sobering reminder that the deepest truths of nature can remake politics, war, and the human conscience. Yet the public myth of effortless genius hides a harder reality, because Einstein worked through loneliness, professional rejection, broken relationships, nationalism, anti-Semitism, and the uneasy knowledge that abstract equations can leave the blackboard and enter history. His face also became shorthand for genius in the new age of cameras and mass media, turning a thoughtful theoretical physicist into a global symbol that newspapers, lecture halls, and later generations could recognize before they understood a single line of his work. To understand how a quiet boy from southern Germany became the most recognizable scientist on Earth, we have to follow him from cramped family rooms and rigid classrooms to patent files, observatories, refugee ships, and the long, unfinished search for a final unity. Albert Einstein was born on March 14, 1879, in Ulm, in the Kingdom of Württemberg, and although his family soon moved to Munich for his father Hermann's electrical business, the household that formed him mixed middle-class ambition, Jewish heritage, music, and practical engineering. As a child, he seemed inward, observant, and strangely resistant to ordinary authority. But a small magnetic compass placed in his hands during an illness convinced him that invisible laws could govern the world with a certainty deeper than anything adults could explain. Music and mathematics became parallel refuges for him, because the discipline of violin practice and the clarity of geometry offered a kind of order that felt cleaner, quieter, and more trustworthy than the noisy demands of ordinary social life. At the Luitpold Gymnasium in Munich, where discipline was sharp and memorization mattered more than curiosity, Einstein chafed against drill-like teaching, retreated into mathematics, and discovered that intellectual independence often begins as a private refusal long before it becomes public brilliance. After failing the general portion of the Zurich Polytechnic entrance examination, and then following his struggling family toward Italy, the teenager found a better path in Aarau, Switzerland, where open classrooms and independent thought gave him the first environment that truly matched his mind. In 1896, he entered the Swiss Federal Polytechnic in Zurich, now ETH, where the young Einstein, restless, skeptical, and already visually thinking through problems, studied physics among future collaborators, including Marcel Grossmann and the brilliant Serbian student Mileva. Their conversations ranged from Maxwell's equations to philosophy and ambition. And while Einstein's confidence attracted friendship and love, his bond with Mileva also created an intimate intellectual partnership that mattered deeply during his formative years. Yet his independence came with a cost, because professors admired his ability less than his refusal to flatter authority. And after graduation, he found himself unexpectedly shut out of the academic posts that seemed the natural reward for a gifted physics student. After months of uncertainty, he accepted work at the Swiss Patent Office in Bern in 1902, and the routine that seemed to bury his scientific career instead gave him a disciplined laboratory of the mind where clocks, signals, machines, and legal precision sharpened his imagination. Working by day and thinking by night with a small circle of friends, he jokingly called the Olympia Academy. Einstein kept returning to one impossible question. What would the world look like if you could race beside a beam of light? And that question became dynamite. In 1905, at just 26, the patent clerk began publishing papers that struck physics from several directions at once. First explaining Brownian motion so convincingly that atoms moved from useful hypothesis towards stubborn physical reality in the minds of skeptical scientists. He then proposed that light could behave as discrete quanta, a radical idea that explained the photoelectric effect and would eventually help shape quantum theory, even though many senior physicists found the claim more unsettling than his later work on relativity. Most revolutionary of all, Einstein's special theory of relativity discarded the comforting ether, fused space with time, and declared that clocks, lengths, and simultaneity depend on motion, so that reality itself had to be measured from the observer's frame. A few months later, he pushed the logic further and wrote the compact relation E equals mc squared, revealing that mass is concentrated energy and giving the 20th century one of its most elegant ideas and one of its darkest possibilities. Recognition came slowly rather than all at once, and as his scientific reputation rose through lectures and appointments, his marriage to Mileva grew strained under distance, ambition, family grief, and the hard truth that intellectual triumph rarely protects private life. From Bern to Zurich to Prague and back again, Einstein rose from clerk to professor, refining the equivalence principle and imagining that a falling observer would feel weightless, an insight that slowly transformed gravity from a force into a problem of geometry. By 1914, he had moved to Berlin for a prestigious position in the Prussian Academy. But Europe was sliding into war, his household was collapsing, and while patriotic manifestos swept through German academia, he stood almost alone among famous scholars in refusing the fever. In those years of separation, exhaustion, and relentless calculation, he struggled toward general relativity, replacing Newton's force of gravity with the curvature of space-time itself, and racing through tensor mathematics with painful intensity before presenting the final field equations in 1915. When eclipse expeditions in 1919 found that starlight passing the sun bent by the amount Einstein predicted, the confirmation turned an abstract theory into a global sensation, and the formerly obscure theorist awoke to cameras, applause, and a new kind of celebrity science. The fame was intoxicating and dangerous at once, because newspapers reduced him to a symbol. Anti-Semitic critics attacked him as a fraud, and the thoughtful physicist with the unruly hair began living inside an image that the modern media machine could endlessly reproduce. Although the world linked him mainly with relativity, the Nobel Committee awarded Einstein the 1921 prize for the photoelectric effect, a reminder that even history's most famous scientists could be honored for the work his contemporaries considered safer and better established. At the great Solvay gatherings, he crossed swords with Niels Bohr over quantum mechanics, pressing thought experiments to defend a lawful universe, while Bohr answered each challenge. And their exchanges became a rare drama in which philosophy, mathematics, and personality shared the same stage. Beyond physics, Einstein used his fame as a platform, advocating internationalism, Jewish cultural renewal, civil liberties, and later racial justice in America, even as his pacifism was tested by rising dictatorship and by the realization that moral principles sometimes collide in history. When Hitler came to power in 1933, Einstein, already traveling abroad, did not return to Germany. And the exile who reached the United States carried more than manuscripts, because he also carried the lesson that brilliance offers no immunity from politics or persecution. In 1939, urged by Leo Szilard and others who feared a Nazi bomb, Einstein signed a letter to President Roosevelt warning that uranium chain reactions could produce unprecedented weapons. And though he never worked on Manhattan Project research, the atomic age would haunt his conscience. At Princeton's Institute for Advanced Study, Einstein spent his later decades as the planet's most famous scientist, and also as one of its loneliest, searching for a unified field theory while younger physicists raced ahead with quantum methods he never found philosophically satisfying. Even as mainstream physics moved beyond him, the elderly Einstein kept answering letters, speaking against fear and conformity, and using his moral authority to challenge prejudice, so that the old man in Princeton became almost as influential in public conscience as he had been in theoretical science. His public stature only grew, and in 1952, the newly founded State of Israel even offered him its presidency. But Einstein declined with humility, recognizing that moral authority, scientific greatness, and political leadership are not the same gift, wearing different clothes. When he died in 1955 at the age of 76, leaving equations unfinished on his desk, the image of Einstein had already escaped the man himself. Yet the final portrait remains deeply human, curious, humorous, stubborn, compassionate, and never fully at peace. Today, his fingerprints remain everywhere, from solar cells and lasers to GPS satellites and cosmology. Because Einstein did not simply add discoveries to science, he changed the scale on which reality could be imagined, and he forced civilization to ask what wisdom should do with power. Einstein's life teaches that imagination becomes revolutionary only when disciplined by mathematics, patience, and the courage to doubt inherited assumptions, which means the celebrated spark of genius was never magic, but a lifelong practice of seeing familiar things from an unfamiliar angle. It also teaches that intellectual greatness does not erase vulnerability, because the man who redefined the universe still wrestled with failed relationships, exile, public distortion, and the moral aftershocks of discoveries whose consequences no single thinker can fully control. If his face endures as a symbol, it is not merely because he was clever, but because he reminds us that wonder and responsibility belong together, and that the deepest questions about nature ultimately return us to questions about how we should live. If this journey through Albert Einstein's mind moved you, like the video, share it with another curious thinker, tell us in the comments which moment changed your view of genius, and subscribe to Great Minds of Humanity for more cinematic histories of the people who reshaped our world.